Hi there, my second grade mathematicians. We will continue our lesson today using various strategies to solve problems with three-digit numbers. Are you ready?
Let's start with our number routine, where we are again thinking about money. Pause the recording while you read the problem to yourself. Use the questions down in the right-hand corner that we have learned about to help understand a problem. When you are ready, start the recording again so we can talk about it. So let's look first at the problem and read it carefully together. Logan had 60 cents in his pocket. He also discovered he has a hole in his pocket and he lost some of the coins. If he only has 27 cents left in his pocket, what coins might he have lost? So you should have thought to yourself, well, this problem is about Logan having money and losing some of it because it fell out through a hole in his pocket. We're trying to find out what coins he might have lost. And in order to do that, we need to know that he started with the 60 cents that was in his pocket, and after he lost some money, he only has 27 cents left. And again, we have to know what coins he might have lost. So let's think about this in a couple of ways. Before you can find the answer to the question, what coins could Logan have lost, you first have to know how much he lost. If you have money and you lose some, you're taking away from your total. That would be a subtraction problem. Remember that with subtraction, you can count back by starting with what he started with, his 60 cents, and then taking away what he was left with, the 27 cents, to see what he lost. Or you can start with what he has left, the 27 cents, and count up to the whole amount he started with, the 60 cents. You could have used any strategy that you wanted to solve the problem, but let's see how this would look if we used a number line to count on to find out how much money Logan lost. So if we do that, this would be our equation. We would be starting with the 27 cents, so let's draw a number line. 27 cents is what he had left when he was done. But we want to jump to 60 cents, which is what he started with, and see how much did he lose along the way. So if we make one jump of 10, that takes us to 37 cents. If we make another jump of 10, that takes us to 47 cents. If we take another jump of 10, that takes us to 57 cents. And now we just have to get to 60 cents. So we're pretty close to that. So we can no longer go another 10 because that would take us to 67. So we can jump by ones, 57, 58, 59, 60. So each of those little jumps was plus 1. So we know that Logan lost 10, 20, 30, 31, 32, 33 cents. Now the question wasn't how much he lost, the question was what coins did he lose? But now that we know he lost 33 cents, we can think about this as what coins equal 33 cents. If we look at what he lost, this 10, this 10, and this 10, how can we connect that to money? 10 cents is the same thing as a dime. So he lost 3 dimes because 3 dimes is 30 cents. And then 1 cent would be the same thing as a penny. And he lost 3 pennies, So 3 pennies would be 3 cents. So he could have lost 3 dimes and 3 pennies for a total of 33 cents. But I'm wondering if that's the only way we could think about it. Now that we know that he lost 33 cents, and we know that 3 dimes, 10, 20, 30, and 3 pennies make 33 cents, what else could we do? You might have said, that's a 10, not a, let me erase that and change that. That should be a 10. You might have said, well, each of these dimes could be a nickel or 5 cents. Or maybe I wouldn't break them both into a nickel. Maybe I'd still have a dime with 2 of the dimes as nickels. Or maybe I'd still have 2 dimes and only 1 of the dimes would have been nickels. I can't do anything else to my 3 pennies, so those remain the same. I wonder if there's another way that I could look at 3 dimes and 3 pennies, though. Well, you might say, I know that 2 dimes and 1 nickel makes 25 cents, because that's 10.25. And if I have a coin that's 25 cents, that's a quarter. So I could have a quarter plus a nickel plus the 3 pennies. Or I could have lost all of I could have had all of it as pennies and had 33 pennies. That's what causes holes in pockets when we carry lots of pennies and lots of change in our pocket, which is generally why people don't want to have a lot of change in their pocket. So any of those ways, those solutions would have worked. 3 dimes, 3 pennies, 6 nickels, 3 pennies, combination of nickels and dimes, or a quarter, a nickel, and 3 pennies. Let's take a look at our try it problem for today. First, pause the recording while you read this problem to yourself, look at the questions at the bottom, and try to answer them. Then come back when you're ready and we'll talk about it. So let's read the problem together. Every day, the Betty family milks and feeds their cows. They also feed their horses. How many cows and horses does the Betty family have on their farm? The first thing I wanted to do when I was trying to figure out this story was to say to myself, well, what is this problem about? And I know that the problem is about the Betty family feeding and milking their cows and feeding their horses. And they have a farm. And then what am I trying to find out? Well, I need to find out how many cows and horses they have on their farm. So the important information I need is how many cows and how many horses they have to know the total number that they have on their farm. Now that I see those numbers, I know that they have 476 cows and 148 horses. Usually when I have a problem like this, those numbers aren't covered up. But the reason that I covered them was so that we don't just jump right in and start solving a problem. We need to think about what the problem's about and what we're being asked to do, and then go look for the information that will help us do that. So now let's read it again. Every day, the Betty family milks and feeds their 476 cows. They also feed their 148 horses. How many cows and horses does the Betty family have on their farm? Again, pause the recording while you solve the problem. When you're ready, come back and we'll talk about it. In our last lesson, we talked about several strategies that you might have used to solve this problem. Let's take a closer look at a few of them here. For our first one, you may have gone to your Ready Math dashboard and used the base 10 blocks. And if you did, this is a good representation of what you might have done. You might not have used the blocks, but you might have done a quick drawing anyway using the base 10 blocks. So as you look at this, you can see that the 476 cows are laid out by hundreds, tens, and ones with our blocks, and our 148 horses are also laid out with our base 10 blocks. Underneath is the equation that would represent this problem, and we would add these two numbers together because we wanted to know the total amount of cows and horses together. So this would be our problem broken out by our groupings, our 500s, our 11 tens, and our 14 ones. You might have also, instead, you might have used this strategy, which we also looked at in our last lesson. And for this strategy, we're focusing on the expanded form. So we looked at 476 and broke it into our hundreds, tens, and ones, and the 148 into our hundreds, tens, and ones. Then we added hundreds together, tens together, and ones together to get the final equation we needed to get the total sum. Today, though, let's take a look at another strategy. And this one, you notice it says is partial sums. Partial means part of the sum. So when we look at this problem, we don't solve the problem by expanding out the number 476 and 148, but instead we think in expanded form. So that we start, in this problem, we started by adding the 400s plus the 100 and getting 500. And we recorded our partial sum underneath the equal sign. This line underneath the two numbers is an equal sign. Then we look at the partial sum for the tens place, and 7 tens plus 4 tens is 11 tens, and 11 tens is the same thing as adding 70 for 7 tens plus 40 for 4 tens and getting 110. And then finally we added our ones place, 14, 6 plus 8 is 14. And you can see the problem, the equation that would represent that at the very bottom. Let me get that, mark that so we can see it. There it is. Not showing up. There we go. So 500 plus 110 plus 14. In the previous one, there was our equation that will lead us to our final answer. There is one more way to look at partial sums. So when you look at this problem, it also says it's partial sums. What I want you to do right now is pause the recording and compare the two partial sums. How are they alike and how are they different? Pause the recording and come back after you've had a chance to look at it. So did you notice that this is actually just the same problem added together in a different order? Instead of starting with the hundreds place like we did in the first one on the left, we started with the ones place on the right. So we see 6 plus 8 is 14. We still added 7 plus 4 to get 110, and the 7 tens and the 4 tens, which is the 70 plus 40, to get 110. And then the 400s and the 100 to get 500. So those two problems are alike, they're just starting in different places to do the final addition. And there, again, is our addition problem that leads us to the final answer, or the sum. So now that we've figured out how do we solve the problem, let's actually do the final computation to see how many horses and cows there were. So if we take a look at this problem, we have 500 plus 110. Well, in 110, there is another 100. So 500 plus that 100 makes 600, plus the 10 makes 610. And then if we add the 14, we have another 10, so we have 624. So our final answer is 624. You can also see that if we look at this problem by adding together these three columns, our hundreds, tens, and ones. This would be 4 ones plus 2 ones. It's not coming out very well. 4 ones plus 2 ones plus 6 ones. So our final answer, 624 cows and horses. That's how many animals, or cows and horses, the Betty family had on their farm. Okay, let's look at this problem. Read it to yourself first. Think about the three main questions that we ask ourselves before trying to solve the problem. They're located in the bottom right corner. And then try to answer those questions. Then go on and solve the problem if you can. Return when you're ready to discuss the problem and the strategies that we could have used to solve it. There was a lot of information in this problem, so it may have seemed confusing or hard to do. But let's look at it using the questions that we ask ourselves and see if maybe it's not as hard as we might have thought. So first of all, let's read it carefully. Carmen has 172 photos of her family. She also has 153 photos of her friends. She has 3 photo albums. Album A holds 225 photos. Album B holds 275 photos. Album C holds 375 photos. Which photo album will hold all of her pictures? Show your work. So as we look at this, we need to think about, first of all, what is the problem about? So we know that Carmen has some pictures, and she's putting them into her photo albums. And she wants to put her pictures of her friends and the pictures of her family together. So that's what the problem's about. You might picture in your mind photos that you might have at home, and you want to put them into an album. You're putting them all together into one album. So then we have to decide, what do we need to find out? Well, the question is asking us which one of the photo albums will hold all of her pictures. She has 3 of them to choose from. And what's going to be important to answer this problem? Well, we know that she has 172 photos of friends. And we know that she has 153 photos. She has 172 photos of family. And she has 153 photos of friends. We also know that she has 3 photo albums. Photo album A holds 225 photos. Album B holds 275 photos. And album C holds 375. So all of those pictures are going to have to go into one of those albums. Let's draw the albums just to keep us a little more organized, because when we have pictures, it often helps us to see what we're talking about. So album A has 225. That's how many it will hold. B will hold 275. And C will hold 375. And all of those pictures circled in red have to go into one of those albums. So if we have those 2 separate albums, those 2 separate groups of pictures, both family and friends, we're going to need to find out how many total together, all the pictures does she have. So we're going to need to add together 172 Actually, let me move this down here. 172 plus 153. Now you might have chosen a different strategy than I am, but I'm going to model this with expanded form. So I'm going to say 172 is 100 plus 70 plus 2, and 153 is 100 plus 50 plus 3. And if I add them together, 100 plus 100 is 200, 70 plus 50 is 120, and 2 plus 3 is 5. I see that 120 is made of 100 plus 20, and I already have 200, and I have 5. So if I put them together, I have 200 plus 100 is 300, and 20 plus 5 is 25. So as we look at those, we see that none of the albums are exactly 325. Could we get 325 pictures in album A? No, it's too small. Could we get them in album B? Nope, that's too small too. Could we get them in album C? Sure, it has more than enough. So album C is our answer. And let's take a look at this place value chart. This is also a good tool to use when solving problems. Pause the recording and decide how you could use it to add the problem shown. 563 plus 127. Come back when you're ready to look at it. So when you looked at this, did you say in the number 563, I have 5 hundreds, I have 6 tens, and there are 3 ones. And with the number 127, I have 100, 2 tens, and 7 ones. So I have 6 groups of 100, 8 tens, and 10 ones. And if I add that together, that would be 600 plus 80 plus 10 ones is 10, which is actually another 10 there, isn't it? So it's 9 tens. So my answer would be 690.
All right, I really hope you enjoyed that lesson. As we wrap up this lesson, though, you have one